This is SpaceTime Series 21, Episode 71. Coming up on SpaceTime. All good aboard the International Space Station following emergency repairs. Reverse polarity sunspots detected on the solar disk. And discovery of a rare binary near-Earth asteroid. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Mission managers say cabin pressure's holding steady following repairs after atmosphere began venting into space from a leak aboard the International Space Station. Mission control centers in both Houston and Moscow worked together with crew aboard the orbiting outpost to close hatches between the space station's numerous modules to try and isolate the leak, eventually tracing it to a pair of holes in the hull of the orbital module of the Soyuz MS-9 spacecraft, which was docked to the Razvet module of the Russian segment of the station. Cosmonauts have now used an epoxy to plug the holes. Flight controllers in Houston are continuing to monitor the station's cabin pressure following the repairs. Meanwhile, mission managers at Star City in Moscow have also undertaken a partial increase in the station's atmosphere using an oxygen supply aboard the Russian Progress 70P cargo ship, which is docked to the station's Pirs Nadir module. The Russian Federal Space Agency Roscosmos has convened a commission of inquiry to try and establish the cause of the 2mm wide microfracture which caused the leak. A micrometeoroid or possibly space junk impact is the most likely cause. The Soyuz MS-09 arrived on station in June and is slated to return to Earth in December. You're listening to Space Time. I'm Stuart Gary. Astronomers have detected a reverse polarity sunspot region on the solar disk. Sunspots are slightly cooler regions on the sun's visible surface caused where magnetic field lines loop out from beneath the photosphere. The reverse magnetic polarity in this region means the sunspot's north and south ends are backwards compared to the normal sunspot polarity in this current solar cycle. The discovery comes as the sun sits at solar minimum, the quietest period in the sun's 11-year solar cycle. The event, catalogued as AR2720, could be the first big sunspot of the next solar cycle. The event's also been associated with a coronal mass ejection and a slow G3 class geomagnetic storm. Coronal mass ejections are powerful eruptions on the sun's visible surface, ejecting billions of tons of stellar plasma and embedded magnetic fields frozen in flux from the solar corona into space. To find out more, Andrew Dunkley speaking with astronomer Dr. Fred Watson.
A reverse polarity sunspot. Please explain.
Well, the first thing about this sunspot, it's really a sunspot group, as all sunspots are, and it's very big. And it's big. That's a surprise because we are at the moment at what we might call solar minimum, which is the sort of minimum period of the sun's activity. Remember, the sun goes through this 11-year cycle. Mm-hmm. In fact, it's actually a 22-year cycle for reasons that I will explain in a moment. But this particular sunspot, I think it appeared about a week ago, a little bit more perhaps. It's designated AR2720, which is a nice number.
Yes.
It's as good as any other. But yes, it is not only large, and it's certainly bigger than the Earth, but it's odd in that, exactly as you've said, it's a reversed polarity sunspot. And the bottom line here is that the sunspots which we see occur in pairs, usually one to the east of the other. So they're kind of horizontally in pairs. They're not vertically or in pairs along a line of longitude, if I can put it that way.
Yep.
So they sit along a line of latitude. And actually their positions change throughout the solar cycle as well. The latitude of sunspots alters. But we're not talking about that at the moment. What we're talking about is the fact that when you've got a pair of sunspots like that, easterly and westerly ones, they have basically their own magnetic fields, which are different in the sunspots of the pair. How do we know about magnetic fields in sunspots, I hear you ask?
I was just thinking that.
There's a technique called Zaman Spectroscopy. So we've talked about the spectrum before, the fact that if you take starlight or light from the sun, split it up into its component rainbow colors, we find that if you do it properly, there is this barcode of actually usually dark lines imprinted on it. And those dark lines are what we call absorption lines. They correspond to the light of a particular element in the atmosphere of the sun or the star being removed by that element. It's a complex process, but they're called absorption lines because the element absorbs the light. And so you've got this imprint on the light of the sun, which otherwise would be a completely featureless rainbow spectrum. It imprints this dark line on it, and there are different patterns of dark lines for different elements. In fact, the sun spectrum is incredibly complicated because it's got so many of these dark absorption lines on it. That's a long way round of introducing this idea of Zaman splitting, which is a phenomenon which was recorded by, I think he was Dutch actually, Herrn Zaman, Z-E-E-M-E-M-A-N, I beg your pardon, Z-E-E-M-A-N. I beg your pardon. Z-E-E-M-A-N.
Depends which part of the planet.
That's right.
I
was talking to a colleague from the United States a couple of weeks ago who said, "What's Z?" Oh, you mean Z? Yay! Great stuff. Anyway, Zaman. So the phenomenon is that if you pass the light through a magnetic field, it splits the absorption into two. They're very, very finely separated. You need extremely high precision equipment to see it, but you can tell from that what the polarity of the magnetic field is. And so that is how the scientists know that this set of sunspots, which has North Pole and South Pole ends of the magnetic field, they're actually backwards way round compared with what they ought to be.
Do they know why?
Not yet, but there's a good hint coming up. So you've got the pairs of sunspots which show opposite polarity. And now I can't remember which way around this is, but normally one is north leading, so north's coming first. But then, and so all your sunspots in one solar cycle would have north leading. But then when you go to the next solar cycle, the next dollop of 11 years, the polarity reverses and you get south leading. So by leading, I mean in terms of its rotation around the sun. So what we're seeing here is one whose polarity corresponds not to the present solar cycle, but to the next one, the one that's coming up.
Okay.
And that's why I said that actually the solar cycle is 22 years, because you've got 11 years with one direction of magnetism, and then 11 years again with the other direction of magnetism. So altogether, that gives you this 22-year cycle. So what's happened is we've got to the end of it. They're all numbered, actually, since they were first observed.
Yeah.
Now, the one that we are observing at the moment is solar cycle 24. If you multiply that by 11, it'll tell you how many years we've been observing them. It's rather a lot. But it looks as though, because this sunspot pair has its polarity reversed, that this might be the first sunspot of solar cycle 25. In other words, it's the start of the build-up to the next solar maximum, because we've kind of gone through a solar minimum. It does tend to happen that at the interface between one solar cycle and another, you will get this mixing up of the polarities. But it's a hint that we are either approaching or certainly very near the minimum of the solar activity. And slow transition from solar cycle 24 to solar cycle 25 seems to have started.
So to use a very rudimentary example, this is like a change of season for the sun.
Yes, that's right. It is, because it's not to do with illumination on the surface of the ground like our seasons are caused by here on Earth. But it is. It's exactly what it is. So the 11-year cycle has been known for many hundreds of years. But the fact that it's actually a 22-year cycle, I think probably only goes back 100 years or so. And so it is a change in the season. Exactly so.
Okay. And is there any impact on us, on this planet?
But always when you've got big sunspots, it tends to imply that there may be solar flares there. And of course, solar flares are what hurl this wind of subatomic particles towards the Earth and give you things like the aurora borealis. And actually on that current space weather page, there is a beautiful photograph of what's called an auroral corona taken from Alaska. If people have a look at the current edition of spaceweather.com, and I should just date stamp it because they change it every day. That's the 27th of August. It's the stunning picture of the aurora. So what that's telling us is that auroral activity is still relatively strong. And this sunspot kind of underlines that. It means that the sun is, even though it's at solar minimum, it's still relatively active. It's not gone completely dormant as sometimes it does in the solar minimum.
Actually, they're suggesting this geomagnetic storm was a bit of a surprise.
Yes, that's right, because we're near solar minimum.
Yeah. So there's some weird things happening on the sun. So it's probably appropriate that we're sending a new probe there to have a look, although it's not really going to be focused on these kinds of events. It's more interested in the corona. But it's just a constant amazing, a constant source of amazement is our little star, isn't it?
Oh, it's sensational what we're learning about it. You know, compared with what we knew 100 years ago when I was a lad, it's blown us out of the water. We kind of vaguely understand now why these magnetic phenomena occur. There seems to be a lot of magnetic activity just beneath the visible surface of the sun, which of course is not a solid surface because it's a gas world.
That's Dr. Fred Watson from the Department of Science speaking with Andrew Dunkley on our sister program Space Nuts. And this is Space Time. I'm Stuart Gary. New observations by 3 of the world's largest radio telescopes have revealed that an asteroid discovered last year is actually 2 objects, each about 900 metres wide. The near-Earth asteroid 2017 YE5 was initially discovered with observations provided by the Morocco Sky Survey back on December the 21st, 2017. But no details about the asteroid's actual physical properties were known until the end of last month. This is only the 4th equal-mass binary near-Earth asteroid ever detected, consisting of 2 objects of nearly identical size orbiting each other. The new observations provide the most detailed images ever obtained of this type of binary asteroid. On June 21st, the asteroid made its closest approach to Earth for the next 170 years, coming within 6 million kilometres of our planet. NASA's Goldstone Deep Space Communications Complex in California took the opportunity to take some close-up radio images of the asteroid. They discovered, much to their surprise, it was a binary system. Problem is, the observations actually revealed 2 very distinct lobes, but the asteroid's orientation at the time was such that scientists couldn't actually see if the 2 bodies were separate or joined. Eventually, the 2 objects rotated, exposing a distinct gap between them. Scientists at the Arecibo Observatory in Puerto Rico had already planned to observe the asteroid when they were alerted by their colleagues at Goldstone about the asteroid's unique properties. And then a few days later, the astronomers at Arecibo teamed up with researchers at the Green Bank Observatory in West Virginia, using the 2 telescopes together in a bistatic radar configuration. This meant that the 305-metre Arecibo dish transmitted a radar signal towards the asteroid, and the 100-metre Green Bank dish then received the return signal. Together, they were able to confirm that 2017 YE5 does consist of 2 separate objects. The findings mean that both Goldstone and Arecibo have independently confirmed the asteroid's binary nature. The new observations indicate these 2 objects orbit around each other roughly every 20 to 24 hours. The radar imaging also shows that both these objects are larger than their combined optical brightness originally suggested. That means the 2 bodies aren't reflecting as much sunlight as a typical rocky asteroid would. Which in turn means 2017 YE5 is probably as dark as charcoal. The original Goldstone images also show a striking difference in the radar reflectivity of the 2 objects. And that's a phenomenon which hasn't been seen previously among any of the more than 50 other binary asteroid systems that have been studied by radar since the year 2000. The reflectivity differences also appear in the Arecibo images, and they hint that the 2 objects may have different densities, different compositions near their surface, or possibly different surface roughnesses. Scientists estimate that among near-Earth asteroids larger than 200 metres, only about 15% are binaries, usually with one object being larger and the other much smaller. Equal mass binaries such as 2017 YE5 are much rarer. Contact binaries, in which 2 similar mass objects are thought to be in contact with each other, are thought to make up another 15% of near-Earth asteroids larger than 200 metres. The discovery of the binary nature of 2017 YE5 provides scientists with an important opportunity to improve their understanding of the different types of binaries and to study the formation mechanisms between binaries and contact binaries, which may or may not be related. Analysis of the combined radar and optical observations may allow scientists to estimate the densities of the 2017 YE5 objects, and that will improve their understanding of their composition and internal structure, and consequently, how they formed. I'm Stuart Gary. This is SpaceTime. And time now to check out the night skies for September on SkyWatch. September is the 7th month of the old Roman calendar, which had just 10 months before the addition of January and February. And that 10-month year is still reflected today with the names September or Septem, being Latin for 7, October or Octa, meaning 8, November or Novem, 9, and December or Deci, meaning 10. In fact, it wasn't until the Gregorian calendar that January first marked the start of the year. But in the beginning, it was mostly Catholic countries which adopted it. Protestant nations only gradually moved across, with the British, for example, not adopting the Reformed calendar until 1752. Prior to that date, the British Empire and its American colonies still celebrated the new year on March 25. Highlight of the month is the September equinox, which this year takes place at 11:54 Australian Eastern Standard Time on Sunday, September the 23rd. That's 21:54 in the evening of September the 22nd US Eastern Daylight Time and 1:54 in the early hours of Sunday morning Greenwich Mean Time. Of course, the day marks the point in Earth's orbit around the Sun when the planet's rotational axial tilt means the Sun will appear to rise exactly due east for someone standing on the equator, and of course set exactly due west. It means almost equal hours of darkness and light. In fact, the very word equinox is derived from the Latin, meaning equus or equal, and nox meaning night. It all comes about because Earth's rotational axis is tilted at an angle of 23.4 degrees in relation to the ecliptic, the plane created by Earth's orbit around the Sun. Earth's axial tilt is always pointed towards the same position in the sky, regardless of Earth's orbital position around the Sun. On other days of the year, either the northern or southern hemispheres are tilted more towards the Sun. But on the two equinoxes, usually around March the 21st and September 23rd, the tilt of Earth's axis is directly perpendicular to the Sun's rays. So, for our listeners in the northern hemisphere, it means the start of fall or autumn, while those of us south of the equator are moving into spring. It's also worth noting that the solstices and equinoxes do change over millennial timescales. They're impacted by something called precession, which causes Earth's spin axis to wobble ever so slightly, just like the axis of a spinning top. Now, the rate of precession isn't much, only about half a degree per century, so people don't notice it on human timescales. But because the direction of Earth's axis of rotation determines at which point in Earth's orbit our seasons occur, precession will cause a particular season, for example the Southern Hemisphere summer, to occur at a slightly different place from year to year over a 21,000-year cycle. At the same time, the orbit itself is subjected to small changes called perturbations. You see, the Earth's orbit is actually an ellipse, not a perfect circle. And there's also a slow change in its orientation, which gradually shifts the point of perihelion, Earth's closest orbital position to the Sun. These two effects, the precession of the axis of rotation and the change in the orbit's orientation, work together to shift the seasons with respect to perihelion. Because we use a calendar year that's aligned to the occurrences of the seasons, the date of perihelion will gradually regress through the complete 21,000-year cycle. Okay, let's start our tour of the September night skies by looking towards the east in the constellation Capricornius, the goat. Capricorn comes from the ancient Greek mythological tale of the demon Typhon. Typhon emerged from a fissure in the earth and attacked Zeus, the king of gods, during a banquet. As all this commotion was going on, the flute-playing goat boy Pan tried to escape by turning himself into a fish and swimming away. However, at the last minute he changed his mind before completing the transformation. He then distracted the demon by playing his flute, giving Zeus enough time to use a thunderbolt he grabbed from the heavens to frighten Typhon away. Because of his actions, both cowardly and brave, Zeus placed Pan in the sky forevermore, still in his half-goat, half-fish guise. The brightest star in Capricornius is Delta Capricorni, also known as Deneb Alcidae, the tail of the goat. It's located 39 light-years away from Earth. A light year is the distance a photon can travel at the speed of light in 1 year, about 10 trillion kilometres. the speed of light being about 300,000 kilometres per second in a vacuum and the ultimate speed limit of the universe. Deneb Algety is a spectral type A white Beta Lyra variable eclipsing binary comprising two stars closely orbiting each other. The total brightness of the system changes because the two component stars periodically pass in front of one another as seen from Earth. Thereby, one of the stars in the system periodically blocks out the light coming from the other star in the system. The two component stars in Beta Lyra systems are both massive giants or supergiants, which are orbiting so close to each other that their shapes are heavily distorted by their mutual gravitational forces. This gives the two stars in the system ellipsoidal shapes, and they experience extensive mass flows from one component to the other. Now, still looking east, but further down on the horizon, below Capricornus, we find the constellation Aquarius, the water carrier of the gods. Greek mythology describes Aquarius as the most stunningly looking youth that ever lived, and so was carried from the earth up to Mount Olympus by Zeus in the guise of Aquila the eagle to become the water carrier. The two brightest stars in Aquarius are Alpha and Beta Aquarii, a pair of luminous yellow supergiants that were once massive spectral type B blue stars. This pair are moving through space perpendicular to the plane of the Milky Way. The brightest of the pair, Beta Aquarii, is a multiple star system located about 540 light-years away. The primary star in the system has about 6 times the mass of the Sun, but it emits roughly 2,300 times the Sun's luminosity, implying a radius at least 50 times that of the Sun. Beta Aquarii appears to have at least 2 faint companion stars, but you'll need a fairly decent-sized telescope in order to see them. The second brightest star in Aquarius is Alpha Aquarii. It's about 520 light-years away, around 6.5 times the mass of the Sun, and some 3,000 times as luminous. Next, let's move to the southern constellation of Pisces Austrinus, the southern fish. The brightest star in the constellation is Fomalhaut, the mouth of the southern fish. It's also the 18th brightest star in the sky. Thousands of years ago, it was used to mark the position of the winter solstice, the Sun's most southerly position as seen from the northern hemisphere. But the precession of the equinox, as we mentioned earlier, has now moved the northern winter solstice to its new position in December. Located only 25 light-years away, Fomalhaut is a spectral type A white-yellow star with about twice the mass of the Sun and about 16 times its luminosity. It's also a very young star, only about 400 million years old. That compares to our Sun's 4.6 billion year age. Fomalhaut also emits excessive infrared radiation, indicating it's surrounded by a circumstellar disk. It's part of a triple star system, together with the spectral type K orange dwarf star TW Pisces Austrini and the spectral type M red dwarf star LP876-10. Okay, turning to the north now, and there you'll see the constellation Pegasus, the winged horse of Greek mythology. Pegasus was the one who delivered Medusa's head to Polydectes, after which he travelled to Mount Olympus in order to be the bearer of thunder and lightning for Zeus. The brightest star in Pegasus is the orange supergiant Epsilon Perseids, which marks the horse's muzzle. Almost 12 times the mass of the Sun, the spectral type K supergiant is nearing the end of its life. Astronomers are still debating whether it will end its days as a core collapse supernova or a rare neon oxygen white dwarf. Also in the north is the constellation Cygnus the Swan, the home of Cygnus X1, the first ever suspected black hole. The constellation lies on the plane of the Milky Way. Cygnus contains the star Deneb, one of the brightest stars in the night sky, and one corner of the summer triangle. It's also home to the giant Cygnus OB2 stellar association. This association includes NML Cygni, one of the largest known stars in the universe, a red hypergiant with about 1,183 times the radius and 50 times the mass of the Sun. In fact, if placed at the centre of our solar system, this massive star's surface would extend past the orbit of Jupiter, containing a volume approximately 1.6 billion times that of the Sun. NML Cygni is located about 5,300 light-years away. Now, as we mentioned earlier, the other highlight of looking at Cygnus the Swan is Cygnus X1, a powerful galactic X-ray source which became the first widely accepted black hole. It was discovered in 1964, and it remains one of the most studied astronomical objects in the sky. This stellar mass black hole is estimated to have about 14.8 times the mass of the Sun, all crammed inside an event horizon with a radius of just 44 kilometres. Located just above the northern horizon right now is Vega. It's the brightest star in the constellation Lyra and the fifth brightest star in the night sky. Vega has about twice the mass of the Sun. It's still a relatively young star, less than 500 million years old, and located just 25 light-years away, making it one of our closest stellar neighbours. Due to the precession of the Earth's rotational axis, Vega was the northern pole star around 14,000 years ago, and will do so again in around another 12,000 years' time. Just above Vega is Alpha Aquilae, or Altair, the brightest star in the constellation Aquila. This is a spectral type A white-yellow star about twice the mass of the Sun. Altair is even closer than Vega, located just 16.7 light-years away. What makes Altair especially interesting is the fact that it rotates extremely rapidly with an equatorial velocity of around 286 kilometers per second. Now, that's a significant fraction of the star's estimated breakup speed of 400 kilometers per second. This high rotational rate means Altair is not spherical, but extremely flattened at the poles. Altair is the eye of the eagle that carried Aquarius up to Mount Olympus to become the water bearer to the gods. If you look to the southeast, you'll see the star Akina, the brightest star in the constellation Eridanus, the river. Located about 140 light-years away, Akina has some 7 times the mass and 3,000 times the luminosity of our Sun. Like Altair, Akina rotates extremely rapidly, in fact so rapidly it's elliptical in shape, with its equatorial diameter about 56% wider than its polar diameter. September also sees the bulk of the Origid's meteor shower. The shower is produced as Earth passes through the debris trail left by the comet KESS C1911N1, a long-period comet which only reaches the inner solar system every 1800 to 2000 years. The meteor shower runs from August the 28th through to September the 5th. The Origid provides up to 5 swift and bright comets per hour at its peak, usually just before dawn. It's best viewed from the northern hemisphere, as its radiant, that is, the direction the meteors appear to be coming from, lies in the northern sky constellation of Central Auriga. The second meteor shower this month is the Epsilon Perseids, which run from September the 5th through to the 21st. Although they're called the Epsilon Perseids, the radiant actually lies closer to the star Beta Perseus or Algol. Now, the Epsilon Perseids shouldn't be confused with the Perseids meteor shower which occurred last month. While they both appear to have their radiance in the constellation Perseus, they're caused by debris trails from 2 very different comets. September also provides an outstanding view of the planets, with Earth's twin Venus as the evening star, just after sunset. And it's worth taking a look either through a pair of binoculars or a small backyard telescope, because during the month you'll see Venus as it dramatically changes phase, from nearly a half phase through to a larger but thinner crescent. Jupiter, Saturn and Mars will also continue their brilliant appearances this month. Just look to the west after sunset. Between September the 12th and the 20th, you'll see the Moon pass from near Venus through to Jupiter, Saturn and finally Mars. And if you have a decent large backyard telescope, you should also be able to spot the rarely seen 2 outer planets in the solar system, Neptune and Uranus. Uranus, which is a bit closer, will also be the brighter of the 2. Both can be spotted in the evening sky. And that leaves only Mercury to be spied, which will pop up above Earth's eastern horizon just before sunrise. You're listening to Space Time. I'm Stuart Gary. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study warns that the deadly 2016 coral bleaching event, which struck the Great Barrier Reef, also affected far deeper reefs than previously thought. The findings, reported in the journal Nature Communications, are based on evidence collected by scientists with the University of Queensland. In the past, deep reefs were often considered as refuges from thermal anomalies caused by global ocean warming. But this new research highlights the limitations to this role and argues that both shallow and deep reefs are under threat from mass bleaching events which are set to worsen thanks to climate change caused by the increased use of fossil fuels. Scientists have developed a new technique which could dramatically boost crop yields by up to 60%. Researchers at the Australian National University placed a carbon capturing mechanism found in blue-green algae called carboxysome into plant cells. In algae, this mechanism is 3 times more efficient at turning carbon dioxide into energy. A report in the journal Nature Communications claims that in plants, it creates a turbocharged engine which could boost crop yields by up to 60%. Well, the big news on the technology front this month is that Apple are expected to announce 3 new iPhones at a press conference on September 12. Included will be the new iPhone XS, which will feature a 6.5-inch display, the largest ever fitted to an iPhone. There'll also be a new 5.8-inch model, the same size as the current iPhone X, along with a more affordable model with a 6.1-inch screen. All 3 are rumoured to include Face ID to replace fingerprint biometrics, with a gesture control system, air-powered charging pads, and a new 4th-generation Apple Watch also on the cards. But don't expect any major software changes this year. That's expected to be put on hold until the arrival of 5G next year. A new study claims that goats can tell when you're smiling or frowning, and they prefer you to be happy. The findings, reported in the Journal of the Royal Society, show that just as humans communicate easily with cats, dogs and horses, it seems some farm animals can also read human expressions. Researchers explored the social intelligence of goats by showing 35 of them images of happy and angry humans. They found that not only can goats distinguish between happy and angry people, but they also seem to prefer happy expressions and spent more time interacting with the happy pictures. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download Space Time as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from SpaceTimeWithStuartGary.com, or from your favourite podcast download provider. Spacetime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more Spacetime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.